Hello, welcome to this session. So quickly about me, I'm Joris. I'm currently working at Photon Data, maintaining the Python bindings to Apache Arrow, and also core developer of Pandas and some other packages.
And I'm Richard Shadrack. I have a background in mathematics. I'm also a core developer of Pandas. And I work for a company called 8451. We're a subsidiary of Kroger, the grocery store in the United States. And there I work on solving large-scale optimization problems.
OK, so in this talk, we want to show you a bunch of improvements that have happened or are coming to Pandas. And nowadays, so many of those larger changes are proposed or are done through what we call Pandas enhancement proposals, or PDEPs. So very similar as you have the Python PEPs, NumPy NEPs, and other projects do something similar. So we adopted this process last year for larger changes in Pandas. So the rest of the talk will mostly be about going through the currently discussed or planned PDEPs. I will just start with two new features from Pandas 2.0, which is already released. So it was released in April. So that's the first one on the list. And in addition, also a change related to the resolution of timestamps. So until recently, if you had a column of timestamps, so a datetime 64 column, under the hood that was using nanosecond resolution. So that's detail how the values are stored. And because of that resolution, you only have a limited range of dates that can be represented, like from 1600 somewhere until 2262. If you have a date outside of that range, you just got an error and you couldn't use a proper datetime column in Pandas. Starting with Pandas 2.0, that's restriction is now no longer the case. So we will support resolutions from nanoseconds up to seconds, meaning you can essentially represent any possible date you would ever want. How does this work in practice? So it's not yet enabled by default in all places, but so for example, if you create a date range, you still get nanoseconds, but if you now explicitly cast it to a different resolution, that will actually preserve that and not silently just stay nanoseconds. Or if you start from a NumPy array and you create a Pandas series from that, if your NumPy array had, for example, milliseconds here, it will now preserve that resolution instead of silently converting to nanoseconds. So this is something actually already changed in the current version of Pandas. Another change that is already included in the release Pandas 2.0, also related to timestamps, but for going from strings to actual timestamps. So if you, for example, read a CSV file, you have a column of strings, you want to convert that to proper timestamps to a datetime 64 type, you would use toDatetime. And so until recently, if you didn't specify a format, what Pandas would actually do under the hood is would just treat each string individually. And so we made a small example here where the first string, it will try to parse it and see, oh, the first thing that I encounter is the month. But then the second string has 13, and it can't take that as a month. So there it will say, oh, the first thing is a day now. And so you get silently very inconsistent parsing of one column of strings. And that's also the reason that I always said when I, for example, teaching, always specify your formats. Then you are sure that it's consistent and it's actually also faster. So now with Pandas 2.0, if you don't specify a format, we will actually just guess the format from the first string to ensure you actually already get a faster parsing, but that is also consistent. And if we guess something wrong, we'll raise an informative error message to indicate you can either specify your own format or still have some fallback if you really have mixed types.
All right. Another really exciting upcoming change in Pandas is PDEP 7, and that has to do with copy and view semantics in Pandas. and a new setting we're calling copy on write. So many users have probably run into the infamous setting with copy warning. A common example of where you might run into this is if you take a data frame, you subset it, say using a Boolean mask, and then you take that subset and you mutate a value, you change a value on that subset. Pandas will raise this setting with copy warning. Now, to understand why Pandas is really raising that, it's important to understand the difference between a view and a copy. So on the left here, we have a view where we have two different data frames, df1 and df2, but they're sharing memory underneath the hood. They're sharing the data that underlies them. And then on the right, you have the same data frames, df1 and df2, except the memory is a copy, so they're no longer sharing the same exact data. Now, whether you're working with a view or a copy in the situation is really important when you go to mutate a value. Let's say we change the value 4 to being a 5. In the case where you're modifying a view, both df1 and df2 will have changed because, after all, they are sharing the same exact data. Whereas when you have a copy, and you can modify just the value in df2 without touching any of the values in df1. And that's exactly why Pandas is raising that warning. You've applied some Boolean mask. You may think you're working with a view. Pandas wants you to know, hey, you're not working with a view, you're working with a copy. When you modify this data, you're not changing the original data frame that it came from. And that's the reason why we raised that warning. So in Pandas today, how do you solve that when you run into the setting with copy warning? Well, there's two different cases here. The first case is you actually want to modify the data frame that you started off with. In which case, if you apply that Boolean mask, then access a column and set the value there, that's not going to work. You're not going to change the actual original value of the data frame. Very surprisingly to most users, I think, if you switch the order of those operations, though, you access a column first, then apply the Boolean mask and set the value there, that will actually change the value in the data frame df here. But it's not really a recommended way to do it. The recommended way is to use .loc. That way you can specify both the Boolean mask and the column selection at the same time, and it's very explicit. Pandas knows what to do, and that will modify the data frame too. The second case is where you don't want to update the data frame when you make this set, when you set the value 10 here. And so in that case, once you apply your Boolean mask to the data frame to get that subset, you have to do this defensive copy. Pandas now knows you know you're working with a copy, and so it won't raise that setting with copy warning. Now, this copy is very much unnecessary. Applying the Boolean mask gives you a copy anyways. That copy is really just to communicate to Pandas you know you're working with a copy, but it's pretty ill-performant. So there's a number of current issues with this, and the first is that it's very confusing to users. You'll see many Stack Overflow posts, blogs, articles written about how to handle this setting with copy warning in Pandas. The second is to really understand whether you're working with a view or a copy, to understand those semantics. You actually also need to know the copy and view details that are down in NumPy as well. And the third we already mentioned is that you have to do these defensive and unnecessary copyings to get rid of the warning. So the question then is, can we do better? And copy on write is summarized in this proposal to have a very simplified behavior. And that behavior is any data frame or series derived from another, in any way at all, will always behave as a copy. And another way of saying this is that mutating a data frame or series only changes the value in that object and no other object. As a consequence of this, if you want to modify a value in a data frame, you have to do it directly to that data frame or series as well. So that's the proposal for copy on write. And it has a number of big advantages. And the first is that it's a much easier to communicate to users, it's much easier to understand, and it's a more consistent user experience. So if we go back to that example where we were modifying that subset by taking first a Boolean mask on our data frame and then using .loc to set a value in it, under this new proposal, the question is, does df change as well? And the answer is a resounding no. Subset's a different object than df, and changing subset will never change df, regardless of how you've created subset. Another advantage to this proposal is we can completely just get rid of the entire setting with copy warning. There's no more users having to understand whether something's a view or whether something's a copy. There are no views anymore as far as the user's concerned. Everything's a copy, and so we don't need this setting with copy warning. So going back to the case where where we have those two different chained assignments, where we just switch the order. Accessing the series first works in modifying the original DF, whereas applying the Boolean mask first does not work in modifying the original DF. So that's the current state today. With this proposal, with copy on write, now instead both of these will, when I either access the column or I subset the data frame using a Boolean series, both of those will act as a copy, and so neither of these will work in modifying the original data frame. Now, if you want to modify the original data frame, you need to do something different, but the key point here is that now it's very consistent for users. Just switching the order here, one doesn't work and one does. So this allows us to get rid of that setting with copy warning, because now no chained assignments will work. But it is rather new behaviors for users. Users may be experienced to, if I access a series first and then apply the Boolean mask, I know it works in modifying the value. If you use copy on write, on the other hand, that won't work anymore. So in this case, when we detect this, we do now raise a warning that we detected the chain assignment, because that behavior will be changing with copy on write. And the last one is that you no longer need these defensive copyings when you're working with data frames. And that can improve both memory usage and the performance of Pandas itself. So going back to the case where we take this subset from the data frame by applying that Boolean mask, and then we don't want to modify the original data frame, we have to do that defensive copy. Well, now that subset always will, no matter how you create it, will always behave as a copy. And so you don't need to specify, take this additional copy to Pandas. So you can just completely get rid of that. But it has a lot bigger implications, actually, when using general Pandas operations. What is a view and what is a copy just becomes an internal implementation detail to Pandas. Under the hood, we're not always making copies. We're actually taking some views on the data and just tracking which data Pandas objects have views on the same data. And then when we have one Panda object try to modify that data, that's when we'll make the copy. And then after making the copy, we can then mutate it safely. And that way, from the user experience, everything behaves as if it were a copy, but we don't have the performance implication of always having to make a copy. Sometimes we just take a view. But again, it's just an under-the-hood implementation detail that the user no longer needs to worry about. And as a consequence of this, there's a lot of cases in Pandas where we make copies today where we no longer need to make copies. So here's a small benchmark where we took 2 million rows, 30 columns, some mix of float, integers, and strings, a typical data set you might see in data science. And we apply a whole bunch of operations to it. Rename, assign, drop, as type, reset index, set index. In Pandas today, without copy on write, every single one of these operations makes a full copy of the entire data set. And as a result, it takes about 2.5 seconds to run. With copy on write, Pandas under the hood is maintaining this track of what data frames are sharing values, what data frames are not, and it's making copies only when necessary. And so with copy on write enabled, actually not a single one of these requires a full copy of your data. And as a result, with copy on write, this now runs in about 14 milliseconds instead. So you can actually try this out today. Pandas released copy on write back in 2.0 as an opt-in, and you can set that mode to be true. We encourage you to use it, try it out. As long as you're not using change assignments, I don't think we expect you to modify your code at all, and you should get some nice performance benefits. We do expect this to become the default behavior in Pandas 3.0, and you can read some blog posts written by both Joris as well as Patrick on the subject, or see the full proposal in our GitHub repository. And of course, feedback is always welcome. Okay. A second bigger change that we are planning for Pandas 3.0 is a new string data type using PyArrow under the hood. So taking a step back, if you currently have strings in Pandas, here I create a small series with a few of strings, you get that as object dtype. If you inspect the data frame, you look at the schema, the data types, and you have some object dtype columns, typically you can assume that most of the time it will be strings, but there is no guarantee about that. And so in the future, we want to have an actual string data type. You can already enable it with that option in the upcoming release. But so, and
become the default in 3.0. But here you see I created the same series, but now we infer you passed all strings, we will make this a string data type. Similarly, if you would read data from any of our I/O formats and you have a column of strings, we will use this data type. Under the hood, this new column, this new data type, is using the PyArrow library, and that library provides fast and efficient way to store strings and to compute things on those strings. So as a result, this new data type will give a significant performance improvement and also improvement in memory usage, while at the same time it should, in theory, be almost fully compatible with whatever we have right now. So at the moment, these object dtype strings, all the string accessor methods, they just use the Python string objects and call methods on those. Now we have faster implementation that should be compatible. I said should be mostly because there will always be small corner cases. For example, in PyArrow, we got a bug report from someone saying that a certain specific German character, it's uppercase, used a different character in Arrow versus in Python, so there might be small differences. But in general, you should be able to upgrade without problems. I said it's faster and more efficient, so let's look at a small example. So here I generate 1 million random strings for varying length, put that in a series using object dtype as of today, convert this to the new string data type as well. And if you use .str.length method to ask what's the length of each of my strings, you can see around a 5 times speed up in this benchmark. Other case using the starts with method to get a Boolean mask. Here it's a bit more than 10 times speed up. So you can get significant speed ups using those string methods from Pandas, while at the same time it's the memory needed to store that column can also decrease quite a bit. And certainly here, our fellow Pandas maintainer, Patrick, also has written a blog post to show some typical workflows in Pandas and actually also in Dask, how this memory improvement helps a lot for Dask to keep the memory lower on the nodes. So there is the bottom link here is a blog post about that. So what's the plan for this? We plan to make this the default in 3.0. Starting with Pandas 2.1, you can already enable it to try it out. And because it's using PyArrow under the hood, PyArrow will also become a required dependency of Pandas, starting with 2.0. That's the main proposal about the string data type. This is using PyArrow. There are also other uses of PyArrow within Pandas. So to start with, we already had read Parquet, read org that were using Arrow. And I also want to mention that if you want to speed up your read CSV call, also there is an engine keyword that you can ask, use the PyArrow backend. And if you have a somewhat well-behaved CSV file, it should run using the Arrow engine, but quite a bit faster. I've been mentioning Arrow, PyArrow, without really explaining what it is. I also don't have time to go in detail. I'm happy to chat afterwards. But Arrow provides, specifies a standard way on how to represent columnar data, so tables. And you have a whole variety of implementations. So PyArrow is a Python binding to the C++ implementation of it. But in addition to the string data type that I showed and some of the I/O methods, another thing that Arrow can mean for Pandas on the longer term is that it supports a whole variety of other data types, and especially some additional data types that is interesting for Pandas because they are currently not really supported. Like, string I already mentioned, but bytes, decimals, dates, nested data, so like struct data, list data. So there's a whole lot more that we can integrate into Pandas. So there is already an experimental Arrow dtype that can just in general store any possible arrow data type. But that's, yeah, you can opt in using those methods, but that's much more experimental. Yeah, that's still actively being developed to integrate those additional data types into Pandas.
And the last we wanted to mention just a couple of PDEPs. The first one has been accepted. The next two are still under discussion. And PDEP 6 has to do with upcasting when you do setitem-like operations. So consider a data frame where you have just one column, integer dtype, and then you set the value using loc in there to 3.5. What Pandas will do today is it'll upcast your integer column now to being floats in order to store this value 3.5. So now all of your data has become floats. And if you do something similar with string and you set that into your data frame, then it's going to upcast to object. And you will have a mix of floats and strings within that column instead. Now, the issue with this is, assigning a value into a series that would cause it to change its data type. There can be different things the user wants to happen. And different users may want different things. And Pandas shouldn't guess. It's always going to guess wrong for someone. And so the behavior we've aligned on is that assignments into existing series that would change your data type in the future will instead raise. So this is going to be, this behavior is going to be deprecated in 2.1. If you're doing this today, you'll start seeing those future warnings on Pandas 2.1, and then will become the default behavior in Pandas 3.0. And you can see the full proposal in the repository. The next PDEP, and this one's currently under discussion, has to do with the in-place parameter in various Pandas methods. I think a lot of users are very surprised when they set that in-place parameter to true, they don't actually see any performance benefit for a lot of the methods. And the reason is it's on a lot of methods where Pandas can't actually do the operation in place. And so they really don't provide any performance benefit and instead just really kind of confuse users. And so the proposal for this one is any method that can't actually be done in place, deprecate the in-place parameter and then remove it come the next major release of Pandas. If the in-place parameter is actually beneficial for performance, we'll keep it. So an example there is fill in A. You can do fill in A in place and get a performance benefit, and so we'll keep that one. So if you are using any in place equals true in the methods we deprecated from, you'll need to change to the in place equals false behavior, assuming this is accepted. And again, the proposal link is at the bottom there. And the last PDEP we'll talk about today is a proposal to change the default behavior of dropna. So just as a motivating example, think about, you're assigned this task of computing the average of groups of 3 runners for a race. So you have a whole bunch of runners, they're all in groups of 3, you want to compute the average for each group. So you take your data, you load up the Excel file into Pandas. Maybe you want to do some QA, make sure every group really does have 3 members. So you do a value counts on the group. You see, you get all the answer 3, everything looks good. So you then go use group by to compute your result, and then save that back out to a new Excel file. But what you may have not realized could happen here is if some of your groups in the original Excel file were blank cells, those will be read in by read Excel as null values. And both value counts and group by have dropna equals true. So you've just accidentally dropped some of your data and you've written back out the result, really without ever seeing it. That can be an issue for various data science tasks. And so that's the real motivation behind wanting to change this dropna to false. And that way, anytime you do want to drop data, you need to specify dropna equals true. It's really apparent from the code that you're dropping values. It's not quite as easy as it might sound. There's a couple of methods that have this dropna keyword. And they don't behave very well if you specify dropna equals false. So as part of Pandas 2.1, we've actually completely re-implemented stack. And you can try it out once we release 2.1. That will become the default behavior in Pandas 3.0, and we will deprecate the current implementation of stack. Pivot tables up next. We haven't worked on that one just quite yet. Another method that gives some questions is mode. There's 2 ways to view mode. You can either view it as kind of counting values, in which case you want it to be aligned with value counts, something like that, where it should have dropna equals false. But you could also view mode as kind of the stats function along with mean and median. Now mean and median and other stats functions in Pandas have skipna equals true as their argument instead. And so under that, guys, you would want to, for just consistency, have skip NA equals true. So we haven't made a decision on what to do here, but you can see, again, the current state of the proposal in the repository.
We already mentioned a few times Pandas 2.1 will have some features you can start using. So when will Pandas 2.1 be released? We actually released on Friday, I think, the first release candidate. So that means that you can actually try it out, give us feedback for anything that might be a regression. I don't have time to go into detail. There are a list of things of other improvements in 2.1 that we didn't mention for the rest. But yeah, so welcome to try it out and to give us feedback on these release candidates. And just to end the presentation, Richard and I have been presenting here a lot of things about Pandas. To be clear, it's not the two of us that made all those changes. Pandas is developed by a whole community of contributors. And so, yeah, this is a thanks to those. And also to mention that you can become part of that community. And for example, by joining on Friday, the Pandas sprint. So a small shout out to that as well. That's it.
Thank you very much. Please give some applause. And thank you very much for your work on Pandas. We are using it every day, so great work. Any questions? Yeah.
Hi, thanks for the talk. I had a question about the string data type thing. What's going to happen with the existing string data type class?
It's going to be integrated into that. So, yeah, it goes a bit into details. Maybe it's a good topic for afterwards as well. But the current string data type already exists, and it's a version of that will become the default. But there are some details about how missing values behave. So you have like the NumPy data types, or at least float has none. This new string data type has NA. And for example, the current string data type, if you then do like this, what I did, for example, with the str.length, you get an integer column. So because the default data type for integer is still the NumPy int64, the string data type version that will become the default in 3.0 will keep, if you derive an int column, those NumPy columns as a default, because that's still the default in Pandas. The current version that is already in the release that you can already use will actually create a nullable int column. So there is still some details there, but essentially it's one of those data types that will become the default.
Thank you for the talk. Talking about arrow data types, when I switch the backend and I try to convert a data type to a PyArrow data type, is a copy performed since we are changing the memory representation? Also, since you're planning to potentially fully support arrow data types, will Pandas have a way to work with structs or schemas for your data frames? Thank you.
So first, is a copy made? That depends. So if you read data from, for example, Parquet file, we are already using arrow, so no copy will be made. If you convert an existing data frame, then it depends on the data type. For example, ints will be 0 copy, strings will create a copy, floats with missing values will also involve some new data, but largely 0 copy. So that depends a bit on the data type. For the second part of your question, I think eventually, or at least in my opinion, for every data type that we currently don't natively support, but that Arrow has, if you want to be able to really use it in Pandas, for each of those data types, we need to add new methods to actually work with that. For example, if you have a struct column, you need to be able to access individual fields of your struct column. Or if you have a list right? A column with a list data type, you need to be able to do things that you want to do with that list data. But that's part of the work in progress. Those better integrations still need to be developed.
Okay, so we are run out of the time. So if you have more questions, please catch Joris and Richard on the hall. And thank you very much. Applause.